If the next global emergency didn't come from our world, but from space? And what if we only had one chance, one single shot to stop it? This isn't just some movie plot. It's a question scientists are racing to answer right now, because the threat, well, it isn't science fiction. It's very, very real.
Okay, so just how real is this danger? To get a handle on that, we have to look up, way up, to the silent, patient threat that's been orbiting our sun for billions of years.
You see, out between Mars and Jupiter, there's this massive cosmic scrapyard called the main asteroid belt. It's got over 1 million rocky leftovers from when our solar system was born. Now, most of them just stay put, minding their own business. But every once in a while, the immense gravity of the planets around them acts like a giant slingshot, flinging one of these rocks onto a path that crosses ours. And that's when they become near-Earth objects, or NEOs. And that is exactly why we have to keep watch.
But listen, not every rock that flies by is a reason to panic. NASA has a special category for the ones we really need to pay attention to, potentially hazardous asteroids, or PHAs. And the most important word there is potentially. It doesn't mean it's gonna hit us. It just means it's big enough and its orbit gets close enough to ours that we have to track it very, very carefully.
So what kind of risk are we really talking about here? This chart, it's pretty sobering. An asteroid just 50 meters across, that's smaller than a football field, could hit us about every 1,000 years and cause city-level devastation. Now jump up to 140 meters, the official PHA size, that's a once-in-20,000-year event. But the damage? We're talking regional, state-level destruction. And the big ones, the kilometer-wide civilization enders, they are incredibly rare, thank goodness. But they're not impossible.
Right. So the crucial thing to understand is it's not a question of if Earth gets hit, but when and by what. But here's the thing. The disaster wouldn't start at the moment of impact. Oh no. It would start the second we knew it was coming.
And make no mistake, our planet is an active target in a cosmic shooting gallery. The evidence is right there in the rock. The Chicxulub impactor wiped out the dinosaurs 65 million years ago. More recently, in 1908, the Tunguska event flattened a forest the size of a huge city. And just in 2013, a meteor only the size of a house exploded over Chelyabinsk, Russia, and its shockwave injured hundreds. This has happened before, and it will happen again.
Just try to imagine it. The moment a credible impact warning goes public, the countdown itself becomes a global disaster. Markets would vaporize overnight. Mass panic could trigger chaotic evacuations, putting an impossible strain on our entire global infrastructure. Just the psychological pressure of that ticking clock, knowing what's coming, that would be a crisis like nothing our civilization has ever faced.
But here's the twist. Facing a threat like this doesn't have to mean facing our end. For the first time in the 4.5 billion-year history of Earth, one species, us, has developed the intelligence to see the threat coming and actually do something about it.
And this isn't some Hollywood script, this is a real-world protocol. Step 1, find them. We have sky surveys like Atlas and Pan-STARRS that are constantly scanning the darkness. Step 2, track them. NASA's experts calculate their exact orbits. Then you characterize them, figure out what they're made of, how big they are. And if the threat is confirmed, the Planetary Defense Coordination Office alerts governments worldwide. And finally, if it's absolutely necessary, you mitigate. You make a plan to stop it.
This quote really gets to the heart of it all. What it's saying is, look, the chance of a major impact happening on any given day is tiny. But the consequences, they're so catastrophic that we simply cannot afford to ignore it. We have to be vigilant, we have to be ready. And all that preparation boils down to the single most critical factor in planetary defense: time. If we find a dangerous asteroid decades in advance, we have so many options. It would only take a tiny little nudge, years before impact, to change its path just enough to miss Earth entirely. But what if we only have months or weeks? Well, then our options get a lot more limited and a whole lot more desperate. By the way, if you're enjoying this kind of deep dive, please consider supporting the channel with a like and a follow. It seriously helps me stay motivated to keep creating content like this for you.
For decades, the idea of deflecting an asteroid was just that, an idea, pure theory. But recently, humanity decided it was time to put that theory to the ultimate test. It was time to stop talking and start doing. On that day, NASA's Double Asteroid Redirection Test, or DART, finally reached its target, a small asteroid named Dimorphos, nearly 7 million miles from home. The mission was brilliantly simple, totally audacious, and had never been done before.
fly a spacecraft straight into it, and see if we could actually move it.
So here's how it went down. Before the impact, the little moonlet Dimorphos was orbiting its bigger parent asteroid every 11 hours and 55 minutes. Then DART, a spacecraft about the size of a vending machine, slammed into it at over 14,000 miles per hour. After the collision, astronomers all over the world pointed their telescopes at it and basically held their breath. The new orbit? 11 hours and 23 minutes.
They did it, a 32-minute change. Humanity had successfully altered the motion of a celestial body. To put that in perspective, the mission's bare minimum for success was a change of just 73 seconds. DART beat that goal by more than 25 times. It was a staggering, unbelievable success.
So, okay, we did it. We proved it's possible. But one amazing test doesn't suddenly give us a foolproof planetary defense shield. It leaves us with some huge questions. Was it just a lucky shot? And how do we turn this incredible experiment into a reliable, repeatable technique we can count on?
Well, the answer to that is coming from DART's international partner, the European Space Agency. They're sending a mission called Hera, which is basically a deep space detective. It's going to travel all the way out to that same asteroid system, arriving in 2026 to conduct a full-blown crash scene investigation and figure out exactly what happened.
Hera's job is to get all the details. It's going to measure Dimorphos' exact mass, analyze the crater DART left behind, and even use radar to see what its insides look like. This isn't just some follow-up mission, it is the absolute critical next step. The data Hera sends back will let scientists turn the kinetic impactor method from a one-time proof of concept into a well-understood operational tool for defending our planet.
So we've seen the technology. We know it's no longer science fiction. We're actually building the tools to protect ourselves. But that leaves one final, crucial, and totally unpredictable variable in the equation. Us, humanity.
So, let's be honest. Are we ready? When it comes to detection, we're getting better every single day. For deflection, DART proved the concept works, and Hera will help us master it. But the ultimate wildcard, the one thing we can't control, is time. Our readiness for any specific threat will always come down to how much warning we have.
And that leads to maybe the biggest question of all. If we were faced with a real countdown to extinction, how would we react? Would a threat from space finally unite us all in a common cause? Or would fear, denial, and chaos just tear us apart and cripple our ability to respond? The technology might be ready, but are we?
I mean, just let that sink in for a moment. For billions of years, life on this planet has been completely at the mercy of the cosmos. Extinction has rained down from the sky before, but we are the first species ever to have the chance to write a different ending to that story. The fact that we can even try is a miracle in itself. So I want to leave you with that question. Let me know what you think in the comments. If that warning came tomorrow, what's our first move as a species? Do we unite? Do we panic? Or do we just deny it's even happening until it's way too late?